Yeah, we're gonna get started in a minute or two. We're gonna be continuing on with our SQL lessons. So yesterday we ended, and we were starting off like starting off the SQL lab, but there was some confusion around the lab, and also there was like some bugs, like not people were struggling to import the CSV files. So I found another lab we can do that doesn't rely on CSV files, and I think it's going to be more fun. Actually, I kind of like this one. That's pretty cool. This is a lab where it's kind of like a little game. Wait, do you all remember Carmen Sandiego? Anyone ever play Carmen Sandiego? Yeah, it's a car. So you have to go find Carmen Sandiego in the SQL database. It's real good. It's on the
in homework for our class, and it was my favorite assignment probably.
Oh, you did that. You did the find Carmen Sandiego in the SQL
as a homework assignment.
Nice. Yeah. This one's cool. I like this one. Oh yeah, I just like this out. It's a lab on how to select data and sort through large amounts of data. That's what's cool about it. We can all get it started up. We can get it set up together, and then we'll work on it for maybe like hour and a half-ish. If we have, it depends, depending on how quickly everyone finishes, we might have another lab to, we'll see. We're going to be working on SQL all night tonight. Okay, so I think most everybody's here. So I'm going to share my screen. So you can fork and clone this this lab that I slacked out. It's like not in. I didn't add it to our org on like it's on open source GitHub, so you'll get some green squares for it when you fork it. And as you can see, it relies on here in the starter code folder. It relies on this world file, which is a huge amount of SQL instructions to insert data. So we shouldn't have any bugs with trying to format like certain kind of characters or whatever. All right, so your job is to chase down the world-renowned thief, Carmen Sandiego. You have to follow the clues and using the SQL database, and there's a file provided for you to store your queries in, so you can run them, or you can type them straight into your SQL, your PSQL shell. This lab is mainly going to it's going to require select statements. You can use some joins if you want to, or you can also use some nested queries like what we saw yesterday. Or for those problems, you can also solve certain problems with 2 SQL statements. That's also valid too. So when you come to those ones, and there's a few ways to solve it. To get started, here I'm going to clone it so we can do it together. Actually, one sec.
We're gonna fork this first.
Yeah, go ahead and fork it. I didn't fork it. Just yeah, you can go ahead and fork it. Okay, so here, I'm gonna open my terminal. So I'm going to cd to SEI. What folders do we have? Let's put this in trainings. because we're doing it in class. And I'm going to clone it down. I'm going to open this up in VS Code just so we can explore some of the code. You can use your regular terminal for PSQL if you want. What is happening? Oh, I'm sorry, that was the wrong folder. Don't make sure to CD into the SQL-Carmen San Diego. Don't be like me and open up code in the parent directory because it's a party file. Okay, so I'm going to open this up. And here in the starter code, so world is what we need to load into the PSQL shell, and clues is where you're going to be doing your work. So there's 7 clues in total. So these are going to be 7 problems you have to solve. Like for example, we recently got word that someone fitting Carmen San Diego's description has been traveling through Southern Europe. So you're gonna have to explore the tables and figure out how to find the information related to this command. Everyone together, let's just load the data in together to make sure there's no bugs. So I'm gonna hit Control backtick and open up my SQL shell. So PSQL. If you're on Windows, it's PSQL-U Postgres. And so here, because I opened this in the project directory that I cloned, I'm going to do \import world .sql. No, I'm sorry. No, not that. It's in starter code. So starter code /world .sql. My bad. So it's in a folder over here, you can see. So \I starter code /world.sql. And this will allow us to import all of the data into our database. So I'm going to press return. And it should load all the data in. So I'm just going to pause here for a second. And it should also switch to world. So, you know, it has all the commands in it, like the files we wrote yesterday. Was everybody able to load the world into their database? Give me a thumbs up. Nice. No bugs? Anyone have a bug? Give me a thumbs down if you have a bug.
What was the command again?
\I starter code /world.sql. And this is in the project, in the folder you cloned it down. Got it? So we can describe tables. So you can see there's cities, countries, and country languages. So these are the same, these are all the tables. So we can \describe each table. So we can see that cities with a T, cities with a T has, you can see the columns with the describe command. There is a large amount of data in each one of these. So if I try to select all from cities, well, it didn't look that bad, but you can see there's so much stuff. So you'll have to use SQL commands to explore the data. If I select all from countries, for example, it looks like there's not enough space for it. So you can make your terminal bigger, or you can do \x auto and then see it.
It was when you put the cities in, it's like a lot of, it's like over 500 of them. Like, is there a command you can do just to like go to the end instead of clicking more every single time?
There's a limit keyword that you can use.
Yeah. You mean like this? Limit 10.
Because right now I'm just holding on enter and it just keeps going. So I don't know when it's gonna end, but I'm sure it will.
I'm sorry, I couldn't really hear what you said. You're trying to do what?
Like right now, I'm just holding enter and it keeps going down one by one on the cities.
Okay, so hit Q.
Q. Oh, okay. Cool.
Yeah. Yeah, so go through the clues one by one, and you'll have to pull out the data that they're looking for. Make sense? Sorry, what's up?
Is there a way to like get to the end of the table faster?
Yeah, writing a more specific query.
Like if for the /x auto, I guess, because I did select all from countries and it's like so many to go through, like pressing enter.
Yeah, yeah. There's so many to go through, which is why you'll have to write some queries to filter through the data.
Ah, okay, got it.
Yeah, that's the whole point. You'll have to like. So here, the first one, we recently got word that someone fitting Carmen Sandiego's description has been traveling through Southern Europe. She's most likely traveling someplace where she won't be noticed. Find the least populated country in Southern Europe. So you can see that each population has a country. You have to find the smallest population out of all of them with a SQL query.
Got it. Thanks.
All right, y'all, I'm gonna open a breakout rooms. We'll probably work on this till like 7-ish or so, or I'll put some pulse checks in the code channel. Hi, y'all, there you go. Alex, is your hand up?
Yeah, just really quick before we go into breakout rooms, what was the command you did to like organize the table if it comes out looking kind of weird?
\x space auto. So extended display auto, \x auto. It's still on my screen, actually. Let me show you. This one.
Okay. \x auto.
You can also make the terminal bigger if you want to see it the other way. Ryan, what's up?
So other than quitting out of SQL, going all the way back to the terminal and clearing your console, is there a way to like just clear the data so it's like you have an empty screen?
Oh, and the SQL shell?
Yeah. Like without having to like, quit out all the way to the main terminal.
Yeah, there is. It's one of these. Let's see. It's definitely not C for clear. Yeah, I'm blanking on what it is.
I mean, it's not that big of a deal, but
Yeah, no, there is one piece that it's not under formatting. Let's see. Let's try and run a command. So this is how you can, if you do exclamation point, it'll run a terminal command. So let's just use Z shell to clear it. So \bang clear. Okay, cool, that works. So that was exclamation point clear. And this runs a Z shell command for your Unix, bash shell. I mean, not Z shell, bash. We use bash in this class. Bash shell.
Sweet. Appreciate it.
You should be able to use the escape too if it's the really long list that you're like stuck in. I think. Oh, it's Q. I'm sorry.
Yeah, Q. And then I just hit escape. It like gave me this. All these are commands. Like gave me a list of commands. Like, are you confused? All right, everybody. So for those of us that are back, we can wait a minute or two before we start reviewing the lab. But how challenging was that lab for y'all? Fist being like it was very, very challenging, 5 being like went awesome. Cool. So I'm seeing some mid to high numbers. Nice, that's good. That's good. We can get some more SQL practice too after this. Well, we can see how review goes and time stuff. Yeah, I'm just gonna wait a minute or two, then we can go over the clues together. All right, y'all. So let's start at number 1. Okay, so we've recently gotten some word that someone fitting Carmen Sandiego's description has been traveling through Southern Europe. She's most likely traveling someplace where she won't be noticed. So find the least populated country in Southern Europe, and we'll start looking for her there. So how can we find the least populated country in the countries table? Hisham.
To select all from countries.
All from countries
Where region
where the region
equals Southern Europe.
Southern Europe. Yeah, so we can look at the region column.
And you can also order by population.
Order by population. So we can look at the so we can do a conditional check for equality on the region column, and we can order by the population. Yep, cool. So Carmen Sandiego is at the Vatican. We can also take this to the next level by using that limit command. If we just said limit 1, so this will return the least populated country, just single. So we have information that Carmen Sandiego is hiding at the Vatican. I feel like she would stick out there, but
I mean, with the red hat and everything, I think she pretty much sticks everywhere.
yeah, for reals. All right, so now that we're here, we have some insight that Carmen was seen attending language classes in this country's officially recognized language. So check our databases and find out what language is spoken in this country so that we can call a translator in for you. So how can we select the, how can we find out what the language is when the language, if we describe countries, if we describe countries, they have a language, they just have a language code, right? They don't actually have it embedded in there, so we can, if we describe country languages, here there's a country code that lines up with the code in the country table. So what do we have to do here? Misha.
We do select star from country languages where country code equals VAT. Return.
Where, yeah, exactly right. So if because we can see here, it's VAT, the code is VAT. So where the country code equals VAT. So we know that they're speaking Italian. All right, so she's taking Italian language classes. So we now know what classes Carmen attended. Our gumshoes tell us she's moved on to a different country, a country where people speak only the language she was learning. So find out which nearby country speaks nothing but that language. So if we just like, so here there's a percentage column in country languages that allows us to see, you know, like the percentage of how much the language is spoken in that country. I was trying to do a select all. So there's different percentages. So how can we find the highest percentage, or where Italian is spoken the most? Jonia.
Do select asterisk from country languages where language equals Italian. And then
where it's Italian. So
yeah.
we're on a filter for only Italian.
Yeah. And then it's only 15 rows. You could see which one has 100% on there.
Yeah, that doesn't have any.
Italian.
Oh,
Oh,
you
did
spelled
I?
Italian wrong.
Yeah. Italian is Italian. Yeah, you're right. Cool.
Yeah.
Yeah, so SMR is. We could also order. We could also order by that column. We could order by percentage.
Mhm.
Percentage. Oh, and we would have to make it descending. So order by percentage descending. And finally, limit 1. So we can select all from country language where the language is Italian. We can order by the percentage column descending. So it starts at the top and descends down, and limit it to 1 query. But yeah, the other way was valid too. It was just, I'm just making it fancier. Okay, so so we're booking the first flight out to, so maybe we've actually got a chance to catch her this time. There are only 2 cities she could be flying to in the country. One is named the same as the country. That would be too obvious. We're following our gut on this one. Find out what other city in that country she might be flying to. So how can we solve this one? Jonio.
So what is it? What we did was the city name was Serra Valley. So then we did the select all from cities where name.
From cities where name.
Like.
Oh, like, nice.
Mm-hmm. And then I just put in Sarah with the SERRA.
Oh wait, you're
with
doing
the
the next one. You're doing number 5.
Oops, I got ahead of myself then.
Yeah. How do we actually find the city name, Sarah?
Oh, okay. Then it's select all from cities where country code equals SMR.
Select all from cities where country code equals SMR. Yep.
Okay.
There we go. Do you want to do the next one too?
Okay.
So we know it's Sarah Valley. So the next one is, okay, oh no, she pulled the switch. There's 2 cities with similar names, but in totally different parts of the globe, exclamation point. She's headed to South America as we speak. Go find a city whose name is like, keyword, one where we are headed to, but doesn't end the same. So we need to select all from cities where name, well, you already did, is,
oh, I put like.
Oh yeah, where name
like.
Yep. Where name is like.
And then SERRA with the percent sign.
Wildcard, yep. And that's it. And so there's Sarah and Sarah Valley. And this one is in Brazil. Wally, what's up?
Okay, so the SMR, my bad. Can you where did you guys get that from? Because I think that probably went over my head. I ain't gonna lie, I didn't finish it. I'm not gonna lie to you. I was like, okay.
Oh yeah, no, it's cool, it's cool. So we got it from Number 3, so we have news on the classes Carmen has attended. Our gumshoes tell us she's moved to a different country, a country where people speak only the same language she was learning. So we know she's in the Vatican, they speak Italian, right? And
Yeah.
then, so
Oh, okay, country code SMR right there for Italian language.
yeah, so it's ordered by percent and limit 1. And so SMR, I don't know what country that's supposed to be, but that's the country code of where they all speak Italian at 100%. So it's ordered by the percentage descending. So the highest first, descending, and then it's limited to be 1.
Cool.
Yeah.
you.
And the reason why all that stuff has changed here, let me find if I can SQL order clauses. There's like a please excuse my dear Aunt Sally of I just Googled this real quick. It's totally something I Google if I'm confused on how to chain things. But so it's an order of operation of SQL clauses. So select from, on, where, group by, having, order by is the order of operations. So you couldn't say like select from, group by, where. You can't do it backwards like that. So it's like always in the same order. So you select from, so select columns from table. And then if there's this is only for a join condition, we don't need those for this assignment. And then you can say where condition. So select from, where condition, and then order by. Yeah. So that's like the order of clauses.
Thank you.
Mhm.
That's sick. This is, oh, okay, cool. I'm gonna take that site.
Yeah, I can check that out. This is like literally just some random site that was like the first Google hit when I Googled SQL order of clauses. Yeah, I can check it out though.
Thank you so much.
Mhm. Yeah, it's like if you can get used to the order, then yeah. Okay, so we were on, so we did the one that where it's like, so our South American, so now we're on number 6. So our South American agent says she just got a taxi to the airport and is headed towards the capital. Look up the country's capital and get there pronto. Send us the name of where you're headed and we'll be right behind you. So we have to use the BRA country code to look up the capital city. So how can we do that? Hisham.
Which one is number 6? Oh yeah. Select capital from countries.
Capital from countries.
Where name equals Brazil.
Name equals BRA, right?
No,
No, Brazil. Oh yeah, right. That makes sense.
Sorry, because we found out that BRA is Brazil. So
Yeah.
and yeah, then we pressed enter. Then we did. Okay, we found 211. Then we did select name from cities where ID equals 211.
Name from cities where ID equals. Oops, ID equals 211. Yeah, that's right. That'll get it.
Dope.
Oh wait,
Brasilia.
Brasilia. Yeah.
Yep.
You could also do a nested query instead of doing 2. So select name. You have to do the first one first. So select name from cities where ID, and this is where you'll do the nested query. So the ID equals, and you open up parentheses to nest a query. And it would be select select capital, right? Capital. So I had a moment where I was like, is this going to work? Yeah, I think this is going to work. Countries where name equals Brazil. And then no semicolon for the nested query, parentheses, semicolon. Cool. That's how you can chain them together. All right, very nice. Okay. So clue 7, she knows we're onto her. This is the last one. Her taxi dropped her off at the international airport and she beat us to the boarding gates. We have one chance to catch her. We just know we just have to know where she's heading to beat her to the landing dock. Lucky for us, she's getting cocky. She left us a note and I'm sure she thinks she's very clever, but if we can crack it, we can finally put her behind bars. It's this funny rhyming note. But what she says is, so I'm off to, on the last bit, I'm off to add 1 to the population I find in a city of 91,000 and now 85. So she's flying there on the airplane. So it's 91,084 right now. So how can we find the city she's going to, knowing that the population is 91,084? Great.
You could select name from cities where population equals 91,084.
91,084. Return. Oh, she's going to Santa Monica. That's right near me. I'll go get her when she flies in. Cool. Yeah, so that's Carmen Sandiego. You all got any questions about this lab, about how we got to where we were with it? Yeah, makes sense. Let's do some more practice. So joins were yesterday. We didn't have to do any joins for this lab. But I want to do a little practice lab with some joins. So if I just want to describe a couple tables and write a join here, we can join cities on their country code. So if we describe cities, they have this country code that's a 3-digit character. So like I'm just going to select all from cities and limit 1. So here's this country code, right? AFG. So this correlates directly. There's a relationship between the country code and if we describe countries, right? So if we describe countries, they have a code. This is in the country table, so they have a code. And so what was this? AFG. So Kabul city was AFG. So if we select all columns from countries where code, so we're saying where code equals this country code that we retrieved, AFG. So where code equals AFG, it's Afghanistan. So cool. Now we've selected Afghanistan from the city, right? So there's a relationship between the cities and countries. One country can have many cities. So the country code of one country can be embedded in many cities, right? In this case, there's just one, but there could theoretically be more than one, right? So let's do a join where we display the table, the data right side by side. So let's say select all columns from cities where, let's not do a where at first. Let's just select all from cities. And so I pressed return and I'm going to join countries. So the way you do a join is you select all the columns from a table and then you join it on another table that has a corresponding foreign key, right? So I'm going to join countries and then you say on. So here you have to say what the 2 columns that line up are, and you can use dot notation to specify columns. So cities dot country code, because remember that's where we got the country code from, equals countries dot code. So select whichever columns you like from the tables, and then you say from where, and then you can say join on another table And then in the on clause, you supply table dot, key equals other table dot key that lines up, right? So here you can see, here's Kabul, and it's joined on Afghanistan. So it joins the data together for us when it displays it. So there's a relationship between countries and cities, right? I'm going to hit Q, get out of that. So let's just do this command, but be a little more specific. Let's select specific rows from cities. So we'll say, what do cities have in them? Cities have a name. So we can say city.name, city.country code. And then we can also do country.name, country.country code. So select cities.name, comma, cities.country code. And we also like to select the other columns that we're going to join, countries.name and countries dot code. So we'll see how the code lines up. We should see the code twice each time, So select cities.name, cities.country code, countries.name, countries.code from cities, join countries. So join's kind of like another from, and you can refer back to it when you're selecting columns, and then on cities.country code equals country.code. And here we can see Kabul lines up with Afghanistan, as does, however you say that, Harriet. Sorry, I hope none of you actually know how to say these. I'm botching it so bad. But you can see that one country can have many cities. So there's this foreign key of the code. Misha.
Can't we create a temp table and store our findings or our results in that temp table and call it later if we needed to, if we wanted to do like an additional join later? Is that possible?
You're describing a join table. So there's a name for that, a join table. A join table is used in a many-to-many relationship. So if you think about it, let's think about like songs and genres, right? One song can have many genres. One genre can have many songs. Well, if you can't embed an array of IDs when you create the relationship. That's not how it works. But there's an intermediary table, and the only time a entry is made into that table is when a relationship is created. So let's say I have a song, I don't know, by like Snoop Dogg, and I want to put it in like the rap category, right? So I just put the two keys, the two IDs in the join table and increment it one time. Then I can look at the join table and see, oh, there's a relationship between 5 and 12. 5 song, 12 genre. Does that make sense?
Sure. I don't know if I asked my question right, but let me think about it now. Ask it again later. Thank you, though.
Yeah. Maybe I misunderstood the question, but yeah, join tables just contain nothing but ID numbers, and every time a new relationship. So if you were going to make another genre, you would embed that in the join table. Yeah. So time is at 7:30. I feel like we could work on another lab to like maybe 8:30, 8:45-ish, and still have enough time for the NoSQL discussion, the SQL NoSQL discussion. So we can get more practice writing raw SQL queries. Let me see. I'm going to pull up a lab. So here's another lab that's it's actually quite broad in scope, but we'll just like scope it in a little bit for the class, so we don't have to do all of it, and we'll slack it out. And this one's cool because it has some joins in it, and it starts off a little bit easier than Carmen Sandiego, and then goes up to a join. So you can practice some joins. So here is the repo. So you can fork and clone it. I'm just going to clone it. I'm going to close this stuff. We'll get it all set up together, so you can close that. I'm gonna cd dot dot and get clone, and it's called Booktown. And I'm gonna cd into Booktown. And I was looking at tonight, there's going to be a SQL practice homework. And so we can import the data here the way we do in the homework. I'm gonna open this up in code doc command, and I'm just gonna chill here for a second while y'all catch up. Amisha, is that the same hand or do you have another question?
It's my bad, sorry.
Good. Now give me a thumbs up when you have it cloned down and you're ready to go. It's like 2 thumbs, so I'm just gonna chill. Got it cloned down? Good to go? Thumbs up? Any thumbs down? You want me to wait a little longer? Okay, cool. I didn't see any thumbs down. So here there's the bookdown.sql. This is going to create the Booktown database. And then there's solutions.sql. This is going to be the prompts. There's quite a few of these. I think it would take probably longer than the time we have in class to work on it. And some of these start off a little bit easier than Carmen Sandiego. The difference between Booktown is going to be a little bit more data. So let's just go up to like number 7. Let's try and get a couple joins done in class, and that's what we'll review. We don't have to do all of these down here. But so I'm going to open up my terminal, and we need to import this booktown.sql, right? So if we want to import data before we have the PSQL shell open, there's a way we can do it. So if I say PSQL on Mac, and if you're on Windows, you have to do this rigmarole. So PSQL on Mac, and we all need to add this flag -F. I forget what F stands for, but it's how you import when you're not in the shell. So this is the same as \I, but not being in the shell. So PSQL-F booktown.sql. And if you're on Windows, you need -U Postgres. So this is just going to import. Oh, I already had it. I already had it in my database, I think. Hold on. Hold on, let me drop that database real quick. Okay, I'm going to try that again. PSQL-F booktown. Cool. Okay. I dropped it in the terminal on my other screen. So what this did is it just copied all the data in there. This is exactly the same as doing \I. It's just you do it from not in the shell. So now we can start PSQL, and we can \C to connect. We can \C to connect to Booktown. So -F imports it when you're just in bash. So we're gonna work on this until maybe for an hour or so. Does anyone have any question or have trouble importing? No, good to go. Matt.
Yeah, just one simple question here. So if I'm in the Booktown terminal, and basically I'm doing PSQL, and then it gives me a Matthew Higgins equals #.
Yeah.
How do I search all my databases existing from here?
Oh, yeah. So you say \L for list.
\L. Okay, and then you do \C to one of the names.
Yep.
Okay, cool. Thank you.
Yep. All right, y'all. I'm gonna open up breakouts and we can work on this. We'll just work till everyone's at number 7 and then review them. And then you can have the extra ones as bonus if you just want even more practice over the long weekend. All right. Rooms are open. All right, y'all. So if you didn't finish, that's okay. Let's just, what I want to do is, I was thinking about, let's review as a class. And if you have any questions, go ahead and field them then. I just would like us to have some time to review together and also move on to the discussion of SQL versus NoSQL. So we can go over the ones we did together. And hopefully that'll kind of give you some traction for, maybe finishing up the rest of the join queries in your, the weekend if you want some extra practice or something. I've gone to like interviews before. I think I mentioned this, like where they've asked me about SQL. For full stack positions, I've never had to do anything more complicated than like selecting stuff from a table. Even for like mid-level positions, full stack roles, I've never had to do something as complicated as a join. I would classify like being extremely comfortable with things like joins and nested queries. I would classify that as intermediate SQL skills, for sure. All right, y'all. Okay, so let's go through this together. So we need to find all subjects sorted by subject. You all know this already. If you describe tables, there are quite a few of them, but this one's asking specifically for subjects. And having to do something like this, like if you get a job at an app, I mean, it's likely they may not even have an ERD, for example. They might, but they may not. So having to explore a SQL database, just purely through some raw SQL commands and checking the data out that way, that's not entirely, out of the scope of what you may have to do in the future. So yeah, that's kind of the purpose of this exercise. Okay, so we need to find all subjects and we need to sort them. We need to have it sorted by subjects. So what do I have to do here to find all the subjects? And Hishan.
Select subject from subjects.
Select subject from subjects.
And you can do order by subjects.
Order by subjects. Yep. I'll just put everything in this file and then run it with a \i solutions.sql. Cool. So all of the possible subjects in order. All right, now what if we wanted to sort this up? We wanted to find all the subjects and sort them by their location. So if we describe subjects, if we describe subjects, there's a location. So how can we find all subjects and sort them by location? Sammy, I'll give you a shot. No offense to the shot you went last time. Just mixing it up.
I think you just replace subjects in the query.
Yeah. So when you order by, so select subject from subject. So select the subject column from the subjects table.
And then you order by location.
Yeah, that's exactly right. It's going to press up. There we go. Cool. Location being like different stores, in Booktown. All right, so let's go to the where clause section. I'm going to comment that out. Okay, so we need to find a book called Little Women. So if we, it's going to describe books. So if we \describe books, they have a title, author, and subject. So we can use a where clause to find a book from the books table. using the title column. So how can we do that? Hisham.
Be right. So we select all from books where title equals Little Woman.
Yep, select all from books. So select all columns from the table books. And then where for our condition clause, where the title equals whatever it is we want to find, which in this case is LITTL, Little Women. And we are semicolon. Cool, there it is. Wally, what's up?
Oh, can I answer the next one?
Yeah, totally. So we need to select all the books containing the word Python. Oh, what do we need to do here?
I did select star from books where title like quotes %sign Python %sign end quotes.
Yeah, where %sign, so wildcard before Python %sign. So there must be someone who's in this unit and they're looking up some books. So I'm going to run this. Cool. And if we wanted to find all cases, we could do lower. I don't think there are any lowercase Pythons, but let's see. Lower Python and lower. Cool. Capitals still match. Okay, so now we need to have a where clause and an order by. So how can we select a subject with a specific location and order it as well? Christian.
You could do select subject from subjects where location equals Main Street and then ordered by subject.
So where, so we're going to select the subject column from the subjects table where the location is at Main Street. And we want to order by subject. What did I spell wrong?
I think you need to capitalize the S in Main Street.
Oh, yeah, that's it right there. Yeah, it has to be identical to this. There we go. Cool. Yeah, it's matching the case. All right. So any questions before we move on to the join sections about the order by clause or where clause? All right. So joins. So we have to find all books about computers and list only the book titles. So the tricky bit here is that if we describe, let's describe the books table. So you can see there is no subject listed here, but there's a foreign key that relates to the subject ID. So if we describe the subject table, subjects table, here the location, it has a location and also the subject is a text, right? So we're going to have to do a join. We're going to have to join the primary key of subjects onto the foreign key that's embedded in a book. So what do we have to do here? Austin.
So we're going to select books.title, since that's what we want to display. From books, join subjects.
Yeah, sorry, I don't know why I'm doing this in the shell and not in the file. Hold on one sec, my bad.
No worries.
So books.title from
books, join subjects
I want to join subjects.
on books.subject ID
Books.
Subject.
Subject ID
equals subjects.id,
subjects.id. Yep, that's it.
where subjects.subject equals computers.
Right, because we need the where clause on top of the join.
Mhm.
So yeah, where subject dot subjects dot subject equals and then
computers. Yeah.
Yeah. So this is here it's where, because we have two tables going on, we have to keep it extra specific. So we say subjects dot subject table dot column.
Mhm.
Cool. Just a note, like dot notation actually always works. So that, like if I just write like well, let me just take one of these for example. We can always use dot notation. So subjects dot subject. This won't throw an error. Dot notation is always valid in SQL. It's not what do you call it? Like a convention to be specific until you do a join. Sammy.
Yeah, actually to that point, I just wanted to ask, because on my code, I just did select title and it did show the same in the end.
Yeah,
So
yeah.
I was just wondering if when we do select, is it just select in the new merge table or?
So this works. And the reason why this works is because you have to have the dots in the on. You absolutely have to, required right here.
Yeah.
But the reason why this works is because if the tables have uniquely named columns, SQL will figure it out which one you're talking to.
Oh, okay.
It's just considered to be best practices to be specific, because you could actually select also like a subject, let's say subjects.location here. You could also select from both tables. So just it's convention to be specific which one you're doing.
Got it. Okay. And it could technically could also be subjects.title, for example, so to avoid any confusion.
Yeah.
Okay. All right. Thank you.
Yeah. So it's kind of convention. And also there's this thing called aliasing in SQL. So it's used in joins a lot. So let's say we wanted to do an alias. Let's say I just wanted to select a books dot title from books. Well, let's start unaliased. So this will just select like that one row with the dot notation, right? So cool. There we are. So if I wanted to give this an alias, I give it a from, and I give it an alias in the from, and it's whatever I want to call this table in my query. So typically it would be B's, like the first letter of the table. So from select B dot title from books aliased as B. You don't have to do the first letter. You can do like banana and banana. So select banana dot title from books aliased as banana. And that still works. I know it's a little confusing because you do the aliasing after you refer to the variable, which seems like a little bit backwards in terms of like how things typically work, but it's how they work in SQL. So in a join, I'm just going to duplicate this join. If you wanted to do an alias, let's say we wanted to call, let's say we wanted to alias books as B and subjects as S. And it's not so important on like a single join between two tables, but if you're joining like 4 tables together, it might be a pain to type out like, the table names over and over again. So we would say select B.title, S.location, and then in the from, we'd alias books. So alias books to B. And then in subjects, we'd alias right here. So subjects S, and then we could say B.subject, S.id. And if you look up joins on the internet, on like Reddit or their Stack Overflow. This is typically how joins are handled with the aliases. So from books B and subjects S, you can define what you want to call them in the from and joins. And this should work exactly the same. Even still here, the aliasing is not required in front of these, as long as you just refer to it as b.s right here. Or b.subject s.id. So that's like a little bit of a dive into, like how you can refer to the columns, like the different ways and when it's important to and when it's just like best practices to. It's only required right here, pretty much. And it's best practices to do it everywhere else, like right here and right here. All right, so let's do number 7, and then we'll call it a night on the books. So find all books and display a result table with only the following columns: book title, author's first name, author last name, book subject. And the subjects, if we describe the table down here, you can see the subjects. Oh, we already went over this. Yeah, the subjects is important. Misha.
I'm good to do this one, right?
Yeah, you want to do it?
So we did select books dot title as in all caps. I did double quotes, book title with the space in between, capital B, or the way they have it. Comma after the double quote. Authors dot first underscore name space as all caps. Double quote.
Name as
Author's first name.
Authors. I got fancy.
Yeah, it's close. And then we comma.
I'm gonna make a new line. I'm actually gonna make a new line right here, and then a new line just so it stays on the screen. But I'll put a comma right there. So comma.
Okay. And then I did authors dot last name.
Authors dot last. Is it underscore name?
Yep, underscore name.
Yes.
As double quotes, authors last name.
Authors last name. Now, I don't think we talked about as yet, but you'll see how this works in just a second.
And then yeah, comma. Then I did subjects dot subject as book subject.
Subject dot subject as book subject.
And I did from books.
Wait, Misha, can I just stop you there so I can run this command and show everyone how as works?
Absolutely.
Cool. So I'm just going to run this, and this is just going to select. Oh, wait, no. I would have to remove. I would have to remove a couple things. Let me just remove these real quick. So if we just select the book's title as books, as book title from books. See right here, it displays book title. So we just renamed it when it went to display it. If the as isn't here, so select books.title from books. You can see it just calls it whatever the column name is. So we could name it anything we wanted right here. Anything we wanted, and it just displays the column as that. So that's how as works. Cool. Okay, so back to it. From books.
From books, and then after that, I did join authors on.
Join authors on.
Books dot author underscore ID. Equals authors dot ID.
authors.id. Cool, nice. So I'll have this nice display.
And then I did one more join for subjects.
Right, so we have to join, so because we're referring to three, yeah, Misha's actually right, I was jumping the gun. So we're referring to books, authors, and subjects in our selection statement, so then we have to rejoin another table again.
Subjects on books dot subject underscore ID equals subject plural dot ID.
Nice, very nice.
Voila.
Voila, that's it. Oh wait, no, that's not it. What's it mad about? Syntax error near authors. Author's first name as. Oh. Missing a comma. Hey, oh, cool. So now we have these really nice display. Yeah, that's a super good use of the of an as statement right there. Cool. So what we've done is we've actually joined book to author and subject, because remember, if we do \d books, it has two foreign keys in it.
Question for readability, when we do as we're doing the alias, is it best to put them on a separate line like you have it?
Yeah, I usually put it on. Okay, so when you have a long selection with as is, I like to do this on separate lines. If I was just selecting one, well, you've seen me do it how I like to do it. I'll put it like all on one line, like that. But yeah, if you have complicated queries like this, each like defined clause typically gets a different line. So well, select got 4, but you know, from books increases readability rather than like having it right there. I guess you could do that. That's not so bad. It's not too bad. But each join typically will get a line 2 for these longer queries.
Okay.
Yeah.
Thank you.
I wonder if there's like a post style guide. I'm sure this thing exists. Oh, hey, well, it's in the Postgres documentation. Oh, no, this is a style guide for their documentation, not for a query. I'm sure such a thing exists on blogs, though, if you search for. Oh, here's a nice one. Yeah, I can select this out. A style guide is just sort of like the syntax best practices. You know, like in JavaScript, like how we camel case, and then like when we have a class, we what do you call it, like a Pascal case or capital case. That's like from a style guide. So here's a SQL style guide that I was looking at. Yeah, so you can read through this and see here it's organized kind of each clause on a different line. Avoid camel case. That's why I've been using underscores. Camel case, it's like some orms use it and like they manage it internally and it's okay, but it can cause problems. So yeah, so this is a pretty good one from what I'm seeing. Oh yeah, columns use their singular name. Aliasing or correlations. Let's see if there's an example of aliasing. Here's one. Yeah, so you can read through here and see the general. Yeah, of course, like if you worked at a place, they'd probably want you to format, you know, your code a certain way. So just do whatever your boss tells you. Make them happy. Here's the code from the review. And so our final thing that I wanted to talk about today, well, y'all got any more like closing questions about the SQL lesson before we Cool. Okay, so here's the SQL versus NoSQL discussion. This will be kind of like, let's see. You don't really need to like fork and clone it. It's mostly like kind of a discussion. So we've been, I mean, throughout the class, I've been comparing and contrasting, differences and similarities, and y'all have gotten some hands-on experience with the difference between SQL and Mongo. I'm curious, like if you could describe SQL, like what is the one word that you would use to describe SQL with, or like what feeling does it give you? We can make a Slack thread. So one word or feeling that SQL gives you. Oops, I spelled that wrong. Tat. I guess it doesn't have to be a word, one word or phrase. I already told you what mine is. It was back on Saturday. It makes me feel like I'm hacking the database and it's like the 80s. Long ass queries, I know. I think that's why it makes me feel like I'm hacking the database. Like each query is so involved. Yeah, easy and hard at the same time. I know exactly what you mean. Like it can be so challenging to craft a query, but then like the language of the queries is like, it's sort of like in plain English, like Python is. Yeah, Rob, I haven't gotten over the equals. I know it's like, and like the crazy thing is SQL uses equals in the where clause for conditional expressions, and then in on clauses and joins, it uses it for assignment. Like, can we get it together? Yeah, it's like a fun puzzle. Wally is not a fan. That's okay. It's 100% okay to have a preference for one technology over another. Yeah. 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 That's funny. All right, y'all. So, I mean, one thing I just want to point out is like systems design questions are getting more and more common in interviews. You might get asked to like, talk about, how you might design a database under a circumstance, or maybe how you write some routes out for a backend, or, even just, you might be asked like about just a simple like full stack application, like a blog, like how would you describe the system for that? So that's kind of where this discussion comes in. We've studied these different technologies in class, and they feel different like when we use them, but like what's their practical application in the real world? So there's going to be a research lab, probably going to take like 15 minutes or so of well, we're kind of a little bit short on time. Let's take 10 minutes for research, maybe like 10 minutes for answering just a few of these questions, but just read through some of these examples. SQL versus NoSQL, ACID versus base. These are kind of like the core ideals of SQL versus NoSQL. Some Postgres use cases and Mongo use cases. And we'll reconvene and talk about it maybe at like 9:10 or no. We'll reconvene at like 9:20 and talk about it. I want you to answer these top 4 questions. So answer those in thread, actually. I'm going to Slack them out. So answer these questions in a thread after you research. Hold on, I'm going to format this nicely. No, I'm not. No, I'm not. 2, 3, 4. Yeah, so have your group answer those. Yeah, and we can talk about it at the end. Alex, what's up?
Should we fork and clone the NoSQL discussion?
There's not really anything to clone. I mean, if you want to make like notes in the markdown or notes somewhere else. You can fork and clone it and like answer these in the markdown if you like, but that's the only real reason to clone it.
Okay.
Yeah, so we're going to spend like 15 minutes or so researching NoSQL and then answering those 4 questions in thread. And we'll reconvene and have a discussion. I'm going to open up breakouts. Breakouts are open. All right, so from what you read, let's talk about number 1. So what are some benefits to SQL databases from what y'all were reading? Sean.
Very efficient. And
Yeah.
Yeah, it's very efficient, and it makes it easier to do like complex queries like we just did earlier.
Yep. It's fast and it handles data complexity really well. I saw some other hands go up. Y'all have anything else to add? I think I saw like Derek, or that Wally, your hands up.
Doesn't require any coding skills. It's like
Yeah.
to do. It's like easy.
It's like beginner friendly. The syntax is for sure. Yeah, that's actually something I never thought about, because like I mean for Mongo, for example, it's like basically just JavaScript. You at least have to know JavaScript. Derek.
I was just going to say, like, it has a standardized schema, right? I don't know if that's similar to what you just said, but
Yeah, no, it's not. That's a really good point. Yeah, so SQL is standardized. We're studying Postgres, which is like the most feature-rich version of SQL, but like y'all are all ready now for SQLite, MySQL, all that stuff. Yeah. Okay, cool. So what about NoSQL? What are some benefits to NoSQL? Wally?
My group said it's developer friendly.
Yeah, it is dev friendly. It doesn't require any it's a lot easier to bootstrap a Mongo database than it is a SQL database, And if you're working on your app and you're like, oh, we need another field in our database, you just add it to your model, right? Easy peasy, can't get easier than that. Matt, I saw your hand up.
Yeah, I was just going to say updating the schema. You just need to turn the server back on.
Updating schema is super easy. And we learned Mongo with schemas, but some of the real power comes when you don't even have a schema, for example. Then it's very, very flexible. Misha.
The data can be unstructured or semi-structured. It's a little different than SQL.
Yeah, unstructured data. Unstructured data is, it's you can do unstructured data in Postgres, but I mean it's still not truly unstructured. You can't put an int where you have a JSON B. Hisham.
NoSQL supports like a lot of data formats.
Yeah, lots of data formats. Yeah, and it's kind of made in sort of like an object-oriented way, right? Like it's sort of anything that has dictionaries or objects translates exactly one-to-one into NoSQL. Christian.
NoSQL is horizontally scalable and can handle more increased traffic.
Yeah, that's true. It can do that. I think SQL can do that too as well.
I thought
Mongo and
is
Par-
SQL not vertically scalable? My apologies.
No, I think they both are. And Mongo in particular is like, the scalable database. MongoDB is, well, actually, this is kind of a nice segue into the next one. So the difference between ACID and base models. Mongo is actually technically ACID these days. There was a really famous blog, I don't know if y'all have read it, Mongo drops ACID. And it's actually pretty recently Mongo has, which is kind of like one of the main direct competitors to SQL. This blog is from 2019. So Mongo version 4, actually, they incorporated full ACID support in MongoDB. So yeah, so there are still true NoSQL databases like Firebase. Google's Firebase is one I can think of. I think like their actual search engine database, the one Google made, is NoSQL as well. Facebook has their own NoSQL database, but yeah. So let's talk about the difference between ACID and base. So what are some differences between ACID and base? Let's start off with ACID. Misha, I see your hand up.
I was gonna ask about the last one. Is Postgres can be used in the cloud? That was just my question before we moved on.
Oh yeah, 100%. So Mongo comes with like the Atlas product, right? So that's like the cloud, Mongo as a service, if you will. Postgres has that as well, but it's not offered by the community that supports like the core of Postgres. So like AWS has their own, Postgres as a service. Microsoft Azure has their own Postgres as a service. So it does exist. I guess like, technically like Heroku, when you deploy it, that's Postgres as a service. So it does have that, but it's not created by the same people who make the actual database, if that makes sense.
No, I get you. Thank you.
So let's talk about acidic databases. Acidic databases is a concept kind of from like the early 1980s. They sort of, SQL already existed, and they kind of like data scientists got together and decided like what is going to make a good database for large apps. What's the ideal we should strive for? And SQL was pushed towards this acidic ideal. So what is the acid ideal? Wally.
I don't really know what the acid ideal, but I did get the acronyms is atomic, consistent, isolated, and durable.
Yeah, and they each have their own meaning. It's kind of like CRUD. Atomic meaning every time a query goes to the database, it's totally isolated from all other queries. So it won't interfere with any other user who's trying to do anything. Consistent means that a transaction, once it's completed, the database is like in like a predictable state. So an atomic transaction happens, no other transaction interferes with it, and the database is returned to a predictable state. Isolated transactions don't interfere regardless of how many there are. There's a data stream going in and out of the database, and the in stream and out stream do not ever like cross the streams. It's like the Ghostbusters, they don't cross the streams. And it's durable, meaning that the data persists even in the event of failure. So even if your database like fails, the data still is not corrupted. So like the data is stored separate from the data management entity. So that stuff. Pretty much like Mongo uses ACID. For production apps that are at large scale, it's something that you desire. But can you think of some drawbacks to using ACID? Like think about how you'd have to make a database work in an acidic way. Like what kind of data structures would you need to use for like the kind of like data pipelines you'd need? Jonia.
That if one of the transactions fails, the entire transaction fails. They don't occur partially.
Yeah,
So,
exactly. If you need to like, let's say you want to, like if you're trying to create a user and like a foreign key or something, if one of them doesn't work, they all don't work. It requires a, like a stack-like data structure for like getting queries into the database. You can't have, two interfering with each other. So you have to like, pipe them in a row, right? So what about base? How does base differ from acid? Junia.
it's to me, it seems a little more flexible in a way, since it's a soft state. So they could change over time, even if there are no reads or writes to the system. And yeah, it's just more flexible, I guess. But
yeah, so like soft state, for example, let's say you have a server serving up, like a base style database. It's going to hold a lot of the data as it's being read and written in memory, right? As it's under heavy load, it might, just flag things to be written and not actually store them any place permanent. If the machine crashes during this process, you may have some data that was supposed to be written that's not written anymore. It's just lost from the computer's memory. But this can increase the speed of transactions, for example, just waiting till there's a smaller load before actually doing, any major like write operations. So yeah, that's like kind of one why I kind of like I think of soft state, like SQL could write to it, like it could write a transaction, then crash, and that transaction would still be like existing when you uncrashed it, basically. But that's not necessarily guaranteed with the base database. The base consistency model. So it's guaranteed that eventually it's going to get caught up, but not necessarily instantaneously. And this is where like the Mongo can outperform, Postgres when it's under extreme loads, for this exact reason. Okay, so that's acid versus base. Yeah, so let's talk about use cases for Postgres versus Mongo. I just want to say it's actually really hard to think of use cases for Mongo where like I think of Mongo as needing like to truly like necessitate the usage of Mongo, you need to have data that's unstructured. That's like the main requirement, right? I mean, outside of any kind of like performant argument. And there's very few, actually Jonia's group posted a really good one. So in gaming, for example, having an unstructured database is useful. But like think about this for a second. If you're familiar with like Xbox or Steam or like GOG or whatever way you play games, PlayStation, how like these days you have cloud backups of games. And like you can like Steam, you can load another computer and have your same save files. Well, it's the game developers that are interacting with like let's use Steam as an example, a Steam API. So Steam exposes this API that game developers can use to give you cloud saves. Now, Steam doesn't have any idea what a game save is going to be looking like. It could be from an older game. It could be from a newer game. It could be in JSON. It can be in some encoded format that's proprietary. So it makes sense for Steam to use Mongo, right? And they just say, you can throw whatever you want into our Mongo database. There's no structure to it. It's up to you, the consumer of this API, the game developer. I feel like the average app, it's like a blog or whatever, a social media site. Typically those have relational type data. So like the average site that we're interacting with on a daily basis would most likely like you need some kind of like some sort of relational structure. I'm trying to think of other examples. Passing data between two apps might make sense to use like Mongo structure, right? Wally?
What about like what we were saying last time, like with YouTube and stuff, since there's a lot of relationships and stuff like that, it's kind of like I feel like that'd be easier.
I think because the data is relational, there's an argument to use SQL there. For like comments and replies and accounts and stuff.
So basically, because there's more relationships, you're saying, well, the data is more relational, whatever.
Yeah, exactly.
That's why you'd go with SQL. Okay, cool.
Yeah, that makes sense. Oh, Matt.
At what point does it start to actually make a difference of like whether you're using one or the other?
Like in terms of like the speed of your database, like in how performant it is.
Yeah, I guess so. Just like when do you start to run into issues? I guess if you're using something you shouldn't.
Yeah, I don't know if like. I don't know if you would like, I don't know if your app is going to crash if you like should have used SQL and you use Mongo, for example. I don't know if you're going to have an unhappy user base because like your transactions are like 50 milliseconds like slower or something like that. Mongo exists because there is a market for there is like instances where like data like needs to be unstructured and it's like more applicable. It came into being because this like needed to be fulfilled. But SQL was there for like years prior to Mongo existing, like, like 3 decades or something. And it was still working, right? It wasn't like the best solution, and that's why another one came up. Another solution was come up with, and that's why Postgres like also started supporting, unstructured data too. So I think probably like when your app is under like when your app is like really popular, it might make a matter in terms of speed. But it won't ever, be like, oh no, we made the totally wrong choice. Now it's not going to work,
Yeah. Cool. Thank you.
Hey, Sean.
I was gonna say, like, wouldn't it also be like depending on like what kind of project you're doing? Like say if it's for like banking, you would rather use like Postgres. I mean, yeah, SQL because it has like more like security.
Yeah.
Instead
that'd be a
of
fair
Mongo.
choice.
All right, cool.
Yeah. Yeah, so I guess at the end of the day, it's you just want to make your choice intentionally. It's okay to like use one because you like it more too. If I was working on like on a hackathon with some friends, I might just use Mongo because it's easier to set up quickly. We're only working on it for a week or something. So there's plenty of valid reasons. I guess you just have a reason why what you're doing, Wally.
I was gonna say like kind of like on what Hisham was saying. But isn't it usually like when you see like old code or legacy code, they're all like just using SQL for the most part. Like I feel like that's, I don't know. Is it just because it's just, I don't know, maybe in one way like more reliable in a sense or something?
Well,
or is it just because it's older? I don't know.
It is because it's older. It's reliable. Like an app. So Mongo kind of exists because Amazon adopted it in the late 90s when it was like a young technology. But I mean, like it's only on version like 5 or something. It's only been like in existence for what, like 20 years or so, 15 to 20 years. SQL's been around since the 80s. It's like ancient. So yeah, I mean, apps that have existed since the 90s, their database was in everyone's was in SQL back then. That was kind of like the only option, unless you were going to gamble with one of the new things, you know. And didn't recently Amazon stop using SQL and they like went with their own NoSQL type? No, they stopped using Mongo and went with their own like NoSQL database.
I believe that.
Yeah, that happened like kind of recently, like within the last couple of years. All right, y'all. That's it. That's not it for SQL. We're going to be using SQL for the rest of the unit, connecting it to a web app. But that's kind of it for today's lesson. So I'm going to slack out. No, I'm going to slack out the homework. Just give me 1 sec. We have 2 pieces of homework, and one of them is kind of important. I have like less than a minute to tell y'all. So, okay, I don't want to keep you over. So, one piece of homework. Where's the homework thread? One piece of homework is about Django. Do that piece of homework before you come to class next Tuesday. We have a long weekend, so everybody enjoy your long weekend. I hope y'all have a good, relaxing weekend and have some fun. Enjoy your Saturday off. We'll see y'all on Tuesday. Please do the Django homework first, so you're ready for Tuesday. There's a SQL practice homework and a Django homework. You'll be in really good shape if you do the Django homework first. So there you go. There's your homework. Have a good long weekend, everybody. I'll see y'all on Tuesday.
Thank you. Have a good night.
Bye. Good night.